backed up using native snapshots. So this is also why we introduced agents in case you have such scenarios in your virtualization environment, just so you can have a single solution which can actually protect everything. Because let's be honest, it would not be convenient if you could do a backup of 98% of your virtual machines with one solution, and then you needed a separate solution just to make sure that those additional machines that have a different configuration are also supported. So not only physical servers, keep in mind that also those virtual ones which are not able to be backed up by snapshots are also supported in our case. So outside of servers, because, well, Veeam is, again, generally known for its data center approach, so to speak. However, keep in mind that with physical agents, if you're looking at Windows, if you're looking at Linux, we can also support workstations. So if you're looking at a personal laptop, like, for example, right now I'm working on my personal laptop, so I actually do have a Veeam Backup installed directly onto it. Of course, I also have a copy of it on my company laptop, but keep in mind that it's not only for data center applications. And I have to admit that it has saved me a couple times. Like, one of the times my laptop was actually, how to say it, too much coffee was actually spilled on my laptop. It was not my fault, of course, never. But I had to get a new laptop. I had to recover everything. And the second time I actually used the backup for my personal laptop is when I was doing quite recently a Windows update. And after the Windows update, my machine just went into an infinite loop of reboots and would never end, right? So again, I had to plug in my backup storage and recover everything. So even though it's not a server, it's a workstation, it is fully supported. So if you just want to have it for your convenience, for example, either for your employees or even for your own home personal use, yeah, why not try and use it? It is actually quite simple to be perceived. Now, how we perform the backup and what are, let's say, the main things that we are trying to achieve when it comes to creating such a backup file, right? So I will get into this into a bit more detail, but basically always image-based backups. So even though there is an agent, it's not a dedicated agent for a specific database. It's not a dedicated agent for example, a file level backup. As you will see, we basically like to treat physical machines as much as virtual machines if we can do so. What are the benefits of it? Of course, yes, we'll get to this. Aside from that, things I believe which are becoming more and more standard today, so incremental backup with change block tracking. So creating incremental backups is simple, right? Because you don't want to have a full copy every single time you perform a backup. Change tracking is something that's a bit more tricky because either you have to use mechanisms which are already included by the vendor platform, and that's not a problem, for example, with virtualization, because you have change block tracking, you have resilient change tracking, for example, in Hyper-V. With physical servers, it's not so trivial. There are different ways to do it. Again, I will, of course, get into this. And the recoveries, so the idea here is that a physical machine should have pretty much the same recovery options as a virtual machine is possible. So the capabilities that exist, and this is also something that can be useful for those of you who have maybe tried out Veeam a couple of years ago, maybe not necessarily have been touching the subject later on, because if you remember, the first iteration of our agent was a completely standalone product. So you had to go install the agent on a specific physical machine, and then you could actually write it to the centralized repository, but this was basically it. There was no centralized deployment. There was no centralized configuration. Of course, over the years, all of this has changed. So right now, if you have, for example, Veeam Backup&Replication already deployed for your virtual environment, the same server can be used for orchestrating all the backups of your physical environment as well, right? So basically everything right now is centralized. And if you hear Veeam Backup&Replication, it's no longer it no longer should be associated with virtual environments. Right now, Veeam Backup&Replication as a server can be basically used for pretty much any kind of backup or any kind of restore for that matter, right? So you should not look at this as a specifically a product created only for virtual environments. When it comes to recoveries, I will not be, let's say, showing you this on the slide. I will show it to you in the demo in just a second. But as I mentioned, for physical environments, all the same things which are also available for virtual machines are available for physicals. Now, coming back to our, let's say, core idea of the backup and why we decided to do so, and also what it means for you as an end user. Because a lot of people, when talking about, what have I clicked? Okay, sorry, I misclicked something. So a lot of people believe that, well, if you're creating a backup of a physical machine, it's usually a file-based backup for some reason, right? Because that's something that we are used to. We've been creating such backups for a long number of years before even image-based backups were something, let's say, on the top, something that was a standard in the industry. We believe that, okay, even though there is a technology, of course, to perform a file-level backup of physical machines, it's actually pointless to do so. Why? Because if you're creating an image-based backup, you can actually extract absolutely anything from such a backup, right? If you have an image of an entire system, you can do bare metal recovery of everything. You can still dig inside the backup file and you can recover individual files. You can dig inside the application, you can recover individual application items if you want to do so. Aside from that, because this is a format which is completely known to Veeam, so basically it's the same VBK, VIB files, so on, this is also a format which can be used by Veeam, for example, for migrating machines between different environments. So this is something that was actually introduced in version 10, but right now we can take any physical backup of a machine and actually turn it into a virtual machine. Right now, only on vSphere environments. In the future, well, we will see. I believe there will be more hypervisors to talk about with this. So because you have a backup of an entire machine, you can have every single recovery option available. So Veeam actually will still give you the option to recover individual, to backup individual files or individual disks of a physical machine if you wish to do so, but just consider the consequence, of course. Maybe you'll get a smaller backup file because you're not saving all the operating system blocks. But when it comes to recovery, you have to take care of having this operating system to recover to. And it becomes simply less convenient. If you have an entire image, you have the operating system in the backup, you can just basically boot it up absolutely anywhere you wish. So why application awareness? This is absolutely, let's say, normal. You don't want the backup to be crash consistent. So the same kind of technologies on the same runtime agent, which is being used for virtual machines, is also being injected into the physical machine. So if you have any application servers which are physical, so if you have like Active Directory, if you have Exchange, if you have Microsoft SQL, if you have Oracle, if you have SharePoint, if you have MySQL, or you have Postgres databases, Veeam can actually understand those. Veeam can quiescence those without any problems. If we're looking at Windows machines, basically any application which also supports the VSS framework will automatically work with the product, right? So the VSS framework will be responsible for the quiescence. So even though we might not have a specific plugin for this specific application, if it's a Windows application, most likely it does support VSS, it understands it, it knows how to basically be quiesced by it. So that way you will have an application consistent backup. When it comes to Linux, by default, we give you file system consistency. If you are looking for specific options for applications other than Oracle, MySQL, or Postgres, basically we use scripts to quiescence those applications. So by default, we're going to put the application in some sort of backup state. So for example, write all the transactions onto disk, so basically empty the buffers, and then we are going to create a volume level snapshot of this machine. And because everything is quiescent, if you do a bare metal recovery, if you do even an individual file recovery, so for example, you recover an entire database as a file, everything is still going to be consistent. You can basically just continue working with whatever you have available. Now, I will start switching to the demo just to show you basically how this centralized management looks like. So hopefully right now you are able to see my demo screen. Well, at least I hope so. Okay. So as I mentioned, everything is being done through the centralized management. So this is going to be the same interface that you are using for virtual machines. Now, keep in mind that right now we have version 10. Of course, I advise you to upgrade it like as soon as possible. We already have a patch 2 to version 10. And the first thing that you have to do when you're creating a backup of physical machines is, of course, make some sort of logical grouping. Because if you think about it, if you think about the old version of Veeam, how we handled physical servers before, every single physical server that was created was basically its own entry, right? So it's not a problem if you have like 10 physical servers, but if it happens that you have, I don't know, 500 physical servers or endpoints, having 500 jobs to manage, well, this basically can become a problem. So the first thing that we are doing is we are creating something called the protection group. So the protection group is nothing else, it's just treating all those physical servers as a single object. So whenever you do any kind of reconfiguration, whenever you define a backup job, it's based on this single object instead of every single physical machine in your infrastructure. Of course, this step is basically optional because you do not have to create like centralized protection groups, but it simplifies deployment and configuration so much that I recommend that everybody actually does that. So let's see basically what the configuration looks like. So the first thing that you have to specify how to add such a protection group. So of course you can specify individual computers, so you can just write IP address or you can write the DNS name of this machine. Again, if you have a couple servers, fine, right? Something, again, more convenient, but still not the best option. So you can just import a CSV file. So if you have a CSV file which contains all of your infrastructure, we can import it into Veeam, and then we're going to parse it, and basically every single machine that was specified there is going to be included in such a job. And lastly, integration with Active Directory. So now with this, we're basically connecting to our domain controller, and this is the option that we are using right here. So with this option, we are going to be able to actually specify a whole container of virtual machines, right? So you specify the options to connect to it. Of course, we need some sort of domain administrator because there is like no local admin on the domain controller, so we have to have access. And right now in here, we've added a single physical machine, but you can of course do it in bulk. So for example, let's look at right here, we have a container which is called computers, for example, right? So we can just add this container, and every single physical machine which is part of this particular container will also be a part of the backup job. Why is this useful? I'll just mention this in a second, because you don't have to worry about having an administrator check if a new machine was added or removed or whatever. Basically, whenever this container becomes reconfigured, so for example, you hire a new employee, you give this employee a new laptop, so you add an entry into your Active Directory, Veeam will automatically see, okay, there is a new entry in this particular container, so we will automatically deploy the agent, we'll automatically add this machine to our backup jobs, just for the sake of convenience. Exclusions, this is normal. And connection parameters, so basically what account is going to be used to connect to our, well, in my case, it's going to be a domain controller, right? So we specify the account which will be used to send the agent, so basically send the agent pack to the physical machine. And now there are actually a couple options here, so we will talk about them a little bit more. So first of all, what is the distribution server? How is this used? Again, if you have a single location, it's basically not a problem if the Veeam central agent, central server, so this is Veeam, is responsible for deploying the agents within such a location, right? Because usually there is like at least a 1 gigabit link between the Veeam server and the machines. The problem starts when you have also a separate environment. So for example, think about having one data center, for example, in Vilnius, the second one, for example, in Klaipėda, and maybe there's a slower link in between the two locations. So you can just consider this a completely separate location. Now, of course, it's possible to have the Veeam backup server connect to every single machine over WAN and basically send the agent. But keep in mind that it's basically like a gigabyte of data which has to be sent to every single machine. And also you need to have all the ports open between the Veeam backup server and every single physical server. So in order to counter that, what we can do is basically we can specify either a dedicated machine, or it actually can be one of those machines that we have in our infrastructure. So this is going to be our distribution server. So what's going to happen is that Veeam is going to send the agent to the distribution server once, and then the distribution server is responsible for deploying the agent within a particular location. So you have a lot less traffic, a lot fewer ports open between the two locations. So that way you're going to have, well, basically a bit more network security also in place. So this is the distribution server. Of course, we want to automatically install the agent once we deploy it. We want to update it in case there is a new version. So for example, you update your Veeam Backup&Replication server and may contain updates to your physical agents as well. So of course, yes, we do an update of that. And What's next? Two checkboxes which are actually quite fun now. So first of all, install the change block tracking driver. Now, why is this option fairly important? Now, if you're looking at Veeam incremental backup, it's being handled differently for workstations, for example, for Windows 10, which I'm using on my laptop, and for example, for a Windows Server operating system. Now, if you are using the workstation, so basically we're using like Windows 10, what Veeam is doing is Veeam is accessing the master file table during the backup. Now, in very, let's say, brief explanation, master file table is going to contain information about the files on our machine, and it also is going to tell us, so basically once we start creating the backup, we ask, dear master file table, what were the changes? And master file table is going to tell us, okay, this file has changed, these two have not changed since you last asked me. So now what has to happen, because master file table only tells us if there were any changes in the file, it does not tell us what were the changes. So right now Veeam knows, okay, so I will skip this from processing, I will skip this from processing, but now in order to find what were the changes, I have to scan this entire file. Now, if this is my laptop, it's not a problem, right? Because, for example, like the biggest file of on my laptop, let's say it's going to be like 10 gigabytes. So still a very quick read, especially with today's SSD drives. So Veeam scans the entire file and then finds, okay, so this block has changed, this block has changed, and this block has changed. So those blocks are then extracted for the backup, right? So even though we have to scan the entire file, only the changed blocks are actually taken into account when performing the backup. Now, as I mentioned, on a workstation, it's not a problem. On a physical server, it may be problematic. If you think about it, and for example, if you think about having an Exchange server, and this is going to be like a 1 terabyte EDB database, and you have a single email basically changing this database, it means we would have to read the entire 1 terabyte just to extract the blocks which are responsible for this single email that was changed since the last backup, right? So it's not something we want for servers. So what we have for servers, and we're no longer touching MFT, so this is our Windows server machine. What we're actually doing is we're installing a driver. So basically we have a driver on the operating system itself. So this is basically this change block tracking driver. Now, this change block tracking driver is actually creating a map. So this is something that you can think of as, for example, a vSphere change block tracking map. So we can call it the CBT. And whenever you have any changes to the files, so basically, let's say we have a couple of files here, whenever certain blocks change in a file, our driver actually intercepts it and stores this data in its CBT map. So whenever basically you make any changes to your files, the driver is fully aware of it and stores this information in the CBT map. So now when we start creating the backup, we do not ask the operating system, but we actually ask our driver, dear CBT driver, what were the changes since the last backup? And then we have exact information which blocks should be extracted. So we do not have to read the file again. We know immediately, let's take this block for backup, let's take this block for backup. And this is basically it, right? So a lot less disk traffic needed for the server operating system. So even though it's not required, it's an optional checkbox. If you are backing up Windows servers, I advise you basically to use this option because it's, well, quite convenient. Okay, and the last thing that can be specified here, well, automatic reboot. Now, this is not a checkbox that's how to say it? It's not a checkbox that's selected by default. I believe we all know the reason why it's not selected by default. Well, of course, you do not want, like, for example, an Exchange farm to start rebooting itself manually. I mean, automatically. You just want to have this as a manual process, for example, running during the weekend. Yeah, so just keep this in mind. Other than that, there are some advanced options. So, for example, we can limit the bandwidth of the agent, so we do not kill your networking, for example. We can restrict that the backup will not happen over, for example, like a cellular connection. We can restrict the backup to specific networks only. And there's also something like one very cool option called the backup I/O control. So the backup I/O control is basically a way for us to ensure that the backup does not kill your physical machine. So what basically happens is this throttling is putting the backup job at a lower priority than other processes. So again, on my laptop, I have this throttling enabled. And basically, I do not see the backup happening. If my laptop is overloaded, basically the backup starts slowing down, slowing down, slowing down. So basically, of course, the backup is slower, but overall, it's not impacting the experience of the user in any way. Now, for servers, again, that's something that you have to be quite cautious with. Why? Because we actually had this case in one of our customers. The customer was backing up a SQL server and was complaining that, well, the backup is running at approximately like 2 or 3 megabytes per second, well, which is a horrible speed, basically, right? So the idea there is that this throttling was enabled, and what's happening with the SQL server? The SQL server, even though it does absolutely nothing, is going to allocate the resources of the physical machine. So even though it was not doing anything, it has put reservation on both the CPU and RAM. So our agent was like, okay, I would like to perform a backup, but let's see if somebody else is using the resources. And then we immediately see from the operating system perspective, okay, there is an application which has basically all the resources reserved, so I can use only the tiny bit of this performance which is left, which means the agent was running basically very slow. Once we disabled the throttling, I believe the speed went up to 700 or 800 megabytes per second. So it was like night and day. It was a completely different experience for the user. So just keep in mind that, well, certain applications have a tendency to break, let's say, the load balancing agent in our case. Now, the next steps, this is basically just installing the agent on those machines, right? So once you have this protection group already enabled. You can see right here that you can actually start creating backup jobs. You can also uninstall, for example, the CBT driver if you want to do so. It's basically up to you what tasks will be performed later on. So, what can you do afterwards? I'll get back to this option a little bit later, because let's first maybe create a backup job, then we'll talk about offsite locations for the backup. Because offsite, of course, is important, but keep in mind everything that I mentioned. We treat physical machines just like virtual machines. So if you have a backup file of a physical machine, it's absolutely not a problem to send it to tape, to send it to other block devices. You can send it to the cloud, for example, to an Azure blob or AWS S3 storage. You can send it to some local object storage if you want to. So basically every single option which you have, again, for virtual machines is available also for physicals, right? So anything can be done there. And of course, we advise you, especially from the ransomware perspective, to either use tapes or use object storage, just because it keeps your data safer from that matter. So now, what backup strategies can be used? So basically, what are the backup jobs that can be configured? Again, I'll switch to my lab here because this is going to be, I believe, a bit more convenient to show it to you this way. So when we create a backup of a computer, so let's choose, this is going to be like a Windows computer. I will just start a new job because that way nothing is going to be grayed out. There are a couple options that have to be considered, basically, right? And they're redundant on the slides. I will just skip the slides later on. So first of all, what type of the job is the agent going to perform? So there's a workstation, server, and failover cluster. So basically, workstation is, of course, used for, like, for example, my personal laptop. So basically, this is creating a copy-only VSS snapshot on my machine, so it's not processing any applications. So for example, if I had a SQL server for some reason installed on my Windows 10 laptop, Veeam would not be aware of it. So basically, we would not be doing any kind of log truncation. We will not be handling the logs in any way. I will not be able to recover individual SQL items if I have any installed there. This is just a backup of my operating system and basically file level consistency of my machines. This is also this also means that we're not going to be able to install the CBT driver, which I told you about, because this is only for the server operating systems. But this is something, again, I can use for my laptops. Second option, so the server, this is basically the processing which we have for virtual machines migrated into the physical environment. So application-aware image processing, the CBT driver, the scheduler, which is very strict. You will also see that in the Workstation edition. The scheduler is a lot different because Workstation backups should have slightly more flexibility as to when the backup is going to be completed. Why? Well, of course, I do not know when my laptop is going to be online. With my physical server, most likely it's going to be online 24/7, so I can say strictly, okay, do a backup at 7 p.m. That's basically it. My laptop, I have no idea. Is it going to be on at 7 p.m. or maybe it's going to be on at 11 p.m. or whatever, right? So you will see that it's a lot different. And the last option that we have right here is the failover cluster option. And this is basically a way for us also to backup clusters on virtual machines. Because what's going to happen is that if you have, for example, 2 cluster nodes, which are connected to some sort of shared storage, sorry for my drawings, I'm not known for great draws. So basically what's going to happen is that we're going to have agent 1 installed on one of the nodes, agent 2 is going to be installed on the second node, and they are going to be aware of each other basically, right? So they know of each other's existence. So what's going to happen is that agent 1 is responsible for backing up the operating system and the shared storage, and agent 2, because agent 1 has already backed up shared storage, is only backing up itself, right? But it knows that if you do any kind of recoveries from this node and you want something from the shared storage, it has to look in the backup files of agent 1. So we have basically full awareness of the cluster. Now, if something happens to agent 1, so for example, you lose this node and suddenly agent 2 becomes the active node, automatically the second agent is also going to be responsible for backing up the shared storage because agent 1 is no longer performing the backup of the shared storage, right? So basically full cluster support, basically also the security that you are not going to be performing backup of any redundant data, because we don't want both agents to do a backup of the shared storage because, well, why waste repository space? Well, disks cost money, so yeah, we just don't want that. So basically, those are the 3 options available for running the agent. Now, there's also a second thing that can be specified here, so the mode in which the agent is going to be running. Let me just maybe also do it this way. So there is managed by backup server and managed by agent. Now, what is the difference? In the first option, so managed by backup server, the agent is just a worker, so to speak. So if we have a physical machine right here and we have the Veeam server right here, so this is our VBR, and this is some sort of physical server to be backed up. What's going to happen is that the VBR server is going to be the user interface. There's the database, which is also going to be the scheduler. We also have all the deployment and configuration as well. On the physical server, the agent is just a service. So basically, it's like a worker, so to speak. So what has to happen in order for the backup to actually complete is that VBR has to tell the agent, because it has the scheduler right here. So it tells the agent, dear agent, perform a backup of this, this, and this with such configuration. And only then the worker starts compression, the duplication, it actually starts creating the backup, right? If for whatever reason you lose connectivity between VBR and physical server, this agent does not do anything, right? Because it does not know when to start the job, it doesn't know what to back up, where to back it up, nothing. This is just a worker. The brains of the operation is the backup server. And this is a mode which is being used for your data center environments. And this is basically good practice to do so because it puts a lot less stress on the physical machine, because we want to keep the agent as light as possible. Now, if you have laptops, for example, then we have the second option, which is managed by agent. And in this case, we're going to have the physical server. We have the VBR server. So once again, we have VBR. We have our physical. And basically, what's happening in this particular scenario? In this scenario, on my physical server, I can have the user interface. I have the database here. It's by default, it's a SQLite. What else? Configuration is being stored here. And my VBR server, in fact, is only used for deployment. It's used for statistics. And it can be also used for reconfiguration. So basically, you can push the reconfiguration between agents, or you can just go to a specific agent and do reconfiguration there. So basically, once the agent has been deployed, if you lose connectivity to VBR, it doesn't really matter because the agent itself already knows, okay, I have a scheduled backup at 8 p.m. and I have to send the backup to this backup storage, for example, right? VBR server is absolutely not required to do so. If the connectivity is there, after the agent has completed the job, it will send statistics to the VBR server just so you can see everything in the centralized console. What was happening? Was the backup successful? Were there any bottlenecks? What was the speed? So on, so on. But the connectivity here is not required, it's optional once the agent is already deployed. And it's very useful for laptops because laptops, well, they tend to switch networks. Sometimes you may want to use cellular. Sometimes you want to connect to some VPN. Sometimes you use Wi-Fi, cable, whatever, right? So you may not always be connected to this company network, which is housing your backup server as well. So let me also modify one of those jobs just to show you what's available here. So then you are going to choose which computer is going to be backed up, and then we have to specify the mode of the backup. So basically, if you specify the mode of the backup, we can also, well, this is actually the part which I told you about. Specify if we're going to really do an image-based backup of the machine, because this is something that's required. Either do an entire computer or a volume-level backup. We also have an option to perform a file-level backup, should you want to do so. However, keep in mind that it also says actually in the interface, it is slower than performing a regular backup. Why? These two options are block-based backup, so whenever you change anything in the file, only chosen blocks will be backed up, not the entire file. In the third option, so the file-level backup, whenever anything is changed within a file, you actually have to take the new version of the entire file. So again, think about this. I'm always using this example like a 1 terabyte EDB database, right? If you have, for example, changes of, let's say, 2 blocks. In the first 2 options, so this is basically this, we only extract those 2 blocks which have changed. In the third option, if we have those 2 blocks changing, we actually have to take the entire file again for the backup, right? So it's not going to be very convenient, especially with large files. Now, my recommendation, always do entire computer. Why? Well, because that way you can recover absolutely anything. With volume level backup, however, you can also specify that you would like to have a backup of the operating system, for example, right? So it's also not going to be a big problem. You can select it, and then, for example, you can skip some sort of data disks. But okay, let's keep the entire computer option right here. You choose the repository, because right now we are doing managed by backup server, so we are writing to a Veeam centralized repository, right? So we choose the retention policy. I can also send the backup offsite, so this is something that I've mentioned. We are both sending the backups to tape. We're also sending it to a different physical location, so basically like a physical block-based array. And because this is a server edition, I have application-aware image processing enabled. And this will also enable me to recover individual items from my Active Directory server, which is being backed up. And I will show it to you, of course, in just a second. And because this is a server edition, as you can see, in a second, yeah, you can see right now, the scheduler is basically very server-based. So specifically at 9:30 p.m., I would like my backup to be running. It's a very strict scheduler. If the server is unavailable at 9:30, well, the backup is going to basically fail. It's going to tell you, okay, backup was not completed because the machine was not available. Now, how does it differ when you are using, for example, a workstation edition agent? Right, so let's create a job for workstation. So let me just actually create a new backup for a workstation computer. So workstation managed by agent automatically. We are going to choose the same machine. I will just click through this quickly because those are the same things that you already seen. Backup mode, again, exactly the same thing as you had just a minute ago. And here are the first differences. So basically, destination where the backups can be sent. In managed by backup server, only this option is available. So basically like a centralized backup repository. If we are backing up a laptop, well, other options can also be used. So it can be, for example, like a USB drive, which you have connected to your laptop. It can be, for example, like a NAS device. This is, for example, something that I'm using at home. I just have like a small NAS underneath my desks, and this is where I store my backups. Of course, it can be a centralized Veeam Backup Replication repository, and we can also send the data to a service provider if you would like to do so. If you don't want to keep your backups locally in your infrastructure. So even though we can still use the Veeam Backup Replication repository, of course, we have to connect to our Veeam Backup Replication server. So this is normal. We have to specify the location, the credentials to it. And the first thing that you can see right here is, for example, difference in retention policy. If you maybe noticed in the server job, you were choosing restore points. In here, you are choosing days, right? Because with servers, you want a strict data protection policy. I want a backup daily for 7 days, for example, so I should have 7 recovery points. With laptops, it can be a lot different. I just want a backup for 7 days. If the backup was running, I don't know, 50 times a day, doesn't really matter from my perspective, right? The laptop, let's be honest, it can be interrupted during production hours. So we should not look at recovery points, especially that you may have a user who is overreactive and the user is going to be basically starting a new backup job every 15 minutes because the user is paranoid. So you don't want a specific number of restore points, you just want a full number of days. And it doesn't matter how many restore points you have within those 7 days. Now, another cool thing with laptops, with the Workstation Edition, is something we call the backup cache. Now, what the backup cache does is that if you have, for example, let's call it a laptop, and you have like a centralized Veeam Backup Replication repository, so by default, we're sending data to this repository. Now, if for some reason this connectivity is lost and the agent is scheduled to run a backup, you can actually specify a bit of your local storage on this laptop, right? So you can have, for example, like, I don't know, 20 gigabytes of space on your laptop, and the agent is actually going to write the incremental backup locally onto your laptop, onto those, let's say, 20 gigabytes of space which you specified. And now, as soon as your connectivity becomes restored to your centralized repository, Veeam is going to empty this cache, send everything to the central repository, and basically that gives you an uninterrupted, let's say, backup schedule, right? So the backup is going to be stored locally for a short time, but as soon as you regain connectivity, it's going to be sent directly to the centralized repository. And the last thing that's different, as you can see, the scheduler is a lot different, actually. So there is no strict policy. Of course, we can say that the backup should run at a specific time and date during the day, if we want to do so. However, there is an additional option that, for example, if the computer is turned off, well, what can I do additionally? Well, if the computer is powered off, I can just skip the backup, right? Or I can actually run the backup in the morning when the user boots up their laptop, right? So it doesn't really matter. Okay, I wanted to perform a backup at 9 p.m., but at 9 p.m. the user was already sleeping, the laptop was turned off. So at 7 a.m. the user booted up their computer. Okay, so now I'm going to run the backup because I skipped it during the night. So that way the backup is going to be performed either way. And this is quite useful. Me personally, I'm actually using these options. So I'm not using the scheduler. I'm using the events trigger scheduler, so to speak. So you can have a backup running every time somebody locks their computer. So, for example, maybe they I don't know, they leave for a cigarette, or they go for lunch, or they go for a phone call. They lock their computer. Automatically, the backup starts running. Other than that, for example, the user leaves the company for the evening. They log off. Automatically, let's run a backup. Again, me personally, I'm actually using the third option. So whenever I get home, I open my laptop sees my NAS device, and then it automatically automatically starts performing the backup. So, for example, if I am outside of my house for like a week, the backup is simply not going to run. It's not going to give me errors. I cannot perform backup because I do not see the repository. It's just automatically going to run the backup as soon as I get back home. I connect to my network, which is also connected to my NAS device. And this is quite, I would say, simple, because that way, as soon as we have network connectivity, the backup is just going to be up and running. Okay, so that's basically it for the backup part of it, so to speak. So I will skip a couple of slides. Also keep in mind that you can actually perform those jobs from the agents themselves. So for example, there's like an interface of the agent which can be used, so you can just click it directly on the physical machine. Right now I'm just showing you the centralized interface because I believe it's more convenient, especially at scale. Now, what can be recovered? As I mentioned, well, basically you can recover everything the same way as you would do for a virtual machine. Let me actually, again, switch to our laboratory. Now, if you look at the backups, just to differentiate and see what are the differences, you have an icon for a Windows machine, Linux machine, and this is what a virtual machine looks like, just so you know within the console what kind of the backup was actually being created at this particular moment. So we've created a backup of my physical domain controller, and something that was actually added in version 10, as you can see. I can take my Windows machine and recover it to VMware and Hyper-V. Now, Hyper-V was there for quite a long time, because recovering data to Hyper-V is quite simple, because Windows machines already have integration services on them. So, well, yes, it's just like basically virtualizing it. Hyper-V understands how to read the operating system. With VMware, we just introduced it in version 10, so this is something fairly new. Now, if you look at a Linux machine, the Linux machine is only available for VMware because, again, on a Linux, we don't have integration services already enabled, but we can virtualize this to VMware as well. Basically, any image-based backup of, well, created by Veeam can be virtualized to VMware, right? So right now I can take my physical machine. I can say that, okay, I would like to recover this physical machine as a VMware virtual machine. We can click through it. So basically, next. I can specify the name of it, connect it to a particular host. I'm not going to connect it to the network because I don't really want it up and running really in my infrastructure. And this is basically instant VM recovery. I believe, I think Mariusz was talking about some of the news that were introduced also in version 10, so I will not be really talking about those too much. And right now, what's going to happen if I go to my vSphere is in a moment we are actually going to see my virtual machine appearing. So let's wait a moment. You can see right here, this is my virtual domain controller. And in a second, yeah, you can see right here, this is actually my physical domain controller, which is actually right now being virtualized. So what's happening underneath is that Veeam is replacing all the virtual hardware with the physical hardware with virtual hardware. So we're also injecting drivers. So vSphere knows how to read this new hardware, because right now the operating system would be completely like basically lost. Like, what's happening? I just had this kind of hardware configuration. Right now I have this hardware configuration. So we just inject the drivers so the operating system knows how to actually handle this. And then you are basically going to have a regular virtual machine up and running, even though it was a physical server just a couple minutes ago, right? So we can see right here, this is the physical to virtual conversion. If you want to perform an old school recovery, it's also not a problem. We can do bare metal recoveries. Now I have to cheat here a little because I cannot do a bare metal recovery because I would have to shut down my laptop. So I actually run it on the virtual machine. So you can actually start the backup from something called the Veeam Recovery Media. And the Veeam Recovery Media is, well, basically it's a recovery environment on your of your backups, of your physical backups. So you start a machine from an ISO file. This is an ISO file. It contains basically the drivers from the operating system which was being backed up. And then aside from certain tools you may have here, so for example, you can reset the password, you can export support logs, you can also load additional drivers to this ISO if you want to. There's the bare metal recovery option. Now, I hope this will work. Unfortunately, we have some networking problems within our vSphere lab, so sometimes we just get timeouts on trying to connect to our backup replication server, but we will see. So you can either point it to the file on local storage. You can also say that the backup file is connected on some sort of network storage. If so, what kind of network storage is going to be used here, right? So for me, it's going to be Veeam Backup Replication repository. So this is the option that I'm using. As you can see right here, I can also configure network settings. This ISO file, so this recovery media, stores my network configuration. So it has found that my original physical machine had one network adapter, and this was basically the configuration of my physical machine. If this is fine, okay, I can continue using this particular configuration. Now, I do not remember, honestly, if this IP address will work for me, but let us see. So I pointed to a Veeam Backup Replication repository, just again, and now I have to connect to this. So it was 10.22.11, if I'm not mistaken. I believe we can do this way. Let's see if I will be able to authenticate. Okay, and then the backup server is basically giving me all the backups which have been found for this particular machine, right? So we can see what was actually happening in my infrastructure here. So then I can choose, okay, which backup is important from my side. Okay, let's choose this, my agent backup, for example. Which recovery points I would like to use here. And the restore mode. And now this is where the things get a little bit fun, actually. So what I would like to recover, I can do an entire computer recovery. So basically everything as it was. I can only recover my C drive if I would like to do so. Or I can do a manual restore. And manual restore allows me to actually map disks according to my own policy, should I want to do so. Now, we can see what was the automatic mapping of the disks. So basically how Veeam wants to recover my disks. So this is going to be basically it. So this was my original disk layout. Okay, and then I can actually create my own if something is wrong. So let's allow it to, again, match the partitions to whatever was in the backup. And then you can also see that we'll be able to resize partitions, we will be able to delete them, add them, so on, so on. So this might take a minute or two. It can also happen that this machine was actually wrongly configured and we don't have enough disks. So it's going to tell us that it's not able to recover into this disk structure. So we will have to do some manual rework here. Actually, just not to waste time, I'll let this run in the background. We'll get back to this in like 2 minutes. And in the meantime, when this is basically auto-matching the disk structure, just to show you what other options are available. So as you remember, we virtualized one of the machines. So right now we can actually migrate this machine using storage vMotion or live migration in case of Hyper-V if you would like to make this into a regular virtual machine. So that's not a problem. And aside from that, as I mentioned, the physical backup is basically exactly the same thing as a virtual machine backup, right? So I can have my physical server, so just like I have right here. And what other options are available when it comes to recovery of the data? Individual volumes, that's normal. guest files, so I can just like extract and I don't know, a specific document from my machine. Application items, because this is my domain controller, I can do so. I can also virtualize this physical machine into a public cloud VM. So if you're an Azure user, if you're an EC2 user, we can actually create an Azure or an Amazon EC2 virtual machine directly from this physical machine backup. It's absolutely not a problem for us. So if you want individual files, again, not really a problem. Just click individual files, next, finish. And right now, Veeam is digging inside the backup file, and it's going to show us the file structure of this machine. So let's say, okay, so actually, my backup server stopped responding to my agent. Like I mentioned, yeah, we have some problems with the networking for some reason from the agent from the vSphere to our physical backup server. We'll try to retry it in a second. Okay, but if you want to recover individual files and folders, let's get back to this. You can just choose which file is the one that you would like to recover. So for example, like right here, we have an ISO file, and then I can either copy it to a chosen location, or I can choose restore. And if I choose restore, it basically injects the file back to my original machine. So actually what we can do, just to show it to you, let's do my remote desktop. I hope you'll be able to see it. Once more. Okay, so you should see my domain controller in here, this PC, disk C, and we have this folder, Veeam agent ISO, for example. Let me delete it. So it's deleted from my original machine, and then I can just recover the entire folder, right? So recover, overwrite, and that's it. Right now we are connecting to my physical machine, and we are going to inject this over the network. So it's like 600 something megabytes, I believe. It's like almost 700 megabytes of data. So right now we're basically authenticating with my physical machine. We're checking what are the options for recovery. So basically, what is the newest state? And then we are already sending this file to my physical server. Right, so we are restoring the folder. And basically everything has been restored already. So the 700 megabytes of data. If we go back here, do a refresh, you can see that this folder is back. The ISO file within it is also back. So fairly simple, no rocket science here, to be honest. Other than that, the last thing that I just wanted to show you is, of course, we are able to dig inside application items. Right here, we have the domain controller. So we can just click it, choose which is the recovery point that I would like to use here. Next, finish. And also, because this is a domain controller, we can actually break something on my physical server, so to speak, right? So let's say, for example, I'm going to delete Master Yoda, or let's see, let's refresh. Okay, let me delete Master Yoda. And let me change something within Darth Vader. So I just changed around some attributes just to, let's say, simulate that something was broken on my domain controller. So if I go back here, but go back to my physical servers, I can see all my users, computers, policies. I can see what was inside the backup files. I can see Master Yoda and Darth Vader are still here. And I can also compare it with production. So I can see what are the differences between the backup and my original server. So you can see right here, Darth Vader has changed and Master Yoda was deleted. So those are the two objects that I can potentially restore. So for Master Yoda, I can recover the entire object. So this is just it. I right-click it, restore everything to production. And this is actually creating a new object and just populating it with all the data. And for Darth Vader, because there were changes, I can compare the attributes with my production server, just so I can see what are the actual differences. And you can see right here what's inside the backup and what's on my production server, right? So you can see which attributes have been modified. And if I would like to recover those two attributes, I simply select them, click Restore, And this is basically the entire process of recovering individual application items, right? So I can close it. I can go back to my physical domain controller. Now I can refresh it. Master Yoda is back, basically, and Darth Vader has his attributes back the same way as they were before, right? So everything just got restored as we would normally expect it. So basically, just to sum up, because I believe we're already running out of time, actually. When it comes to physical servers in general, well, you can't really treat them as physicals anymore. You have to look at them basically as operating systems, as machines, because this is what we're trying to achieve here in Veeam, is that you should no longer care whether the backup was taken of a physical machine, of a virtual machine. As you can see right now, we can virtualize physical machines. We can actually send them as cloud VMs. So we're trying to give you as much mobility of the data as you need. So even if you have virtual machines, which for some reason cannot be backed up using, for example, a vSphere snapshot, you should not really worry about that. Just install an agent inside this virtual machine, treat it like a physical VM, and then you can still recover it absolutely anywhere into your infrastructure, right? So this is something to keep in mind. Physical is not something we should be afraid of anymore. Even if you are looking for data mobility, this is what we are trying to give you. Now, just a last remark, if you are using this agent, try to keep it as an entire computer backup. Just use those image-based backups. That's what Veeam has been doing since forever. We know how to do this. And as you've seen, it gives us the most recovery options you can possibly think of. So not only it simplifies the backups because of the change block tracking drivers and everything, but most importantly, it simplifies recoveries, because if you have a backup of an entire machine, not only individual files or like a specific data disk, you can just virtualize it. You can recover it on the side. You can, of course, still extract individual files and folders. Basically, you have every single recovery option. If you want to try it out, feel free to contact me. Feel free to contact Bluebridge. They know what they're doing. They will help you with the configuration, with the architecture of the design. So feel free to try it. I hope you like it. And just remember, not only virtual environments right now, virtual, physical, cloud, basically everything. So this is it from my side. Well, thank you very much for having me today.